Hi folks, Tom Affolter here again, and today we're going to talk a little bit about ANSI SQL and designing tables. Designing a database is our first topic, and when you design a database, it's a pretty complicated process. You want to make sure that whatever you do is going to be flexible, efficient, and also secure. So just like when you're going to design software, you want to make sure that you have a team approach when it comes to taking a look at what your application, or in this particular case, what your database is going to do or how it's going to perform. So you're going to want to have input from the end users being the people who are actually sitting down using this on a day-to-day basis. Those people that currently have a process in mind, they understand the system. You're also going to want to have the programmers involved, because you want to make sure that whatever you design, you have a programmer's approach to that. You understand what their process is, what their needs are. You're also going to have the software developers. Now again, programmers and software developers might be two different positions, if you will. A software developer might not be a programmer at all. They might simply be a person that sits down, designs the process, decides what the screens are going to look like, and then turns that design over to a programmer. Obviously, a software developer has to be integrally involved in that database design to make sure that whatever they're designing on the front end, on that look and feel, matches what that database can provide, and if not, making sure that the database does provide that. You obviously have to have supervisors and administrators involved in that, and the supervisor and the administrator input would be from a variety of different standpoints. Obviously, they're looking at it from a functionality. Does it provide the reports and the information that I need back to make my business type decisions? And then you need your financiers. The financiers would be stakeholders just like the rest of them, but they have, and of course a lot of these positions, by the way, may be overlapping, but the financier has the responsibility of making sure that you're paid and making sure that what you're doing is within their financial ability to get the job done. And of course the return on their investment is going to be there. And then, of course, any other stakeholder in that organization that you might think would have valid input on the process. And of all these people, and of course they're all vitally important, you're going to find out that the end user is going to be the most important person, because they're the person that currently knows the system. The other people don't know the system. Obviously, programmers and software developers don't know the system. The supervisors and the administrators may set out the guidelines, but it's the end users, the people that work in the office, the data entry people, that actually know the system. They're also the hardest people when it comes to change that you have to make happy. So there are a lot of different college classes dedicated to how you write and design databases. This class is not intended for you to become a database designer after you finish this. The whole focus of this is that you are needing enough information to be a developer, a software developer that's utilizing a database that might at some point in time have to sit down and design a small database, or might have to on the fly within your code design a database that you might use for just a brief moment and then discard. Okay. So it's very important for you to know that, but also understand that if you're expecting after this class to be able to go back in and design a large-scale database, it's not going to happen. I would highly recommend that if you are going to be responsible for a large-scale database, that you want to sit down and take an in-depth theory class on understanding the whole concept of databases, relations, and how to make those the most efficient. I'm not saying that you can't do it. In my early days, before database or SQL database became large, I was creating these databases myself without that past experience. But I would be the first to tell you, though, that there were a lot of stumbling blocks I came across that, had I understand the theory a little bit better, would have made my life easier. And again, the concept of designing a table or a database is not that difficult. But how to make these relations together to make them the most efficient, that's where it becomes a little bit more difficult. So I do want to point out, though, that a large percentage of both desktop, mobile, and web applications are database driven, and I would venture to say that you're probably looking at a vast majority, if not 90%, of all the programs that you're going to use out on the internet today or that you're going to utilize on your desktop have some kind of database connectivity feature in them. So this is one of the most important skills, as I've been preaching through this entire course, that you can build. But we're going to understand, again, in this class, just a brief focus on what design is about, just a small focus of that. And then we're going to sit down and start talking about how to create those tables by hand and within a designer. And then I'm going to give you my philosophy behind that. So there's two different approaches to designing a database. One approach is the top-down approach, and another approach is the bottom-up approach. The top-down approach is by far the older type design approach, and we're going to take a look real briefly at both of these. So the top-down approach starts with a general idea and moves to the more specific. So let me stop and let me take an example that's happened in my career. I developed the first commercial animal control software that was used in the United States. And at some point in time, I had to sit down and start talking about design. So I used, and this was back in the 1980s, what's called the top-down approach. The top-down approach says, be as general as you can when you sit down and you start the project, and then you work into the more specifics. So you start off at the very top of what we would call the pyramid here, and the pyramid says, get down to the brass tacks. What is this about? So in the general side of it, if I was going to do animal control, I would say something like, my responsibility is to track the dogs within a general community. That's the general purpose of my site. And then I would start working my way down into the more specifics. So we have this conceptual model, this what is the purpose of what you're doing, and then we break it down into what we would call entities. Now again, within this class, I'm not going to quiz you on this, I just want you to understand the basics. We have this concept called the entity relationship diagram, and the ERD says how are tables related to one another. So let's back up and talk again about that term entity. Entities would be, if you will, the nouns involved in the particular database, the things that you're tracking. So if I was going to look at tracking dogs, I would say, well, I need to track the dog himself, I need to track the owner. These are all the nouns involved. So the dog, I have the owner, I have the dog itself, I have the licenses. If the dog is licensed differently every year, I might have impounds from that dog, I might have citations from that dog. Those would all be the individual things that I might want to track. And then when I get down from those things, I start talking about the attributes. So in a database design, you start off with the specifics, and by the way, the attributes would be the fields. So if I'm tracking a dog, what would the fields be with that dog? So I design the database, and after the database is designed, then I start as a software developer designing the application around that database with the understanding that that database design can constantly change. So we start off very general. Here is what I'm going to do. Then we start looking down that pyramid and getting more and more and more specific until we get it finally done at the very end. And that's the top-down approach. The bottom-up approach is a little bit different. The bottom-up approach begins with the specific details. So if I was designing, and this is again a newer approach, in fact, this today we talk about an agile type approach, a needs-based approach. So I would get my stakeholders involved again in a room like we were talking about before, and rather than talk about that pyramid approach, the top-down approach, what I would start asking all my users is basically, what do you want the program to do for you? What do you want out of the program? So for example, the data entry people would probably start in the animal control or the dog licensing program. The data entry people would say, well, I want to track dog license. I want a data entry form that allows me to put the owner's name in, blah, blah, blah. Perhaps the supervisor might come back and say, I want a report of the financials. I want to know every month how much money was generated from dog licenses. I want to know how many impounds, blah, blah, blah. So you go down this and you start getting all the needs together and then you start designing the database around those specific needs. And basically the idea is if you work on everybody's individual needs and you try to put it in one cohesive unit, that eventually what comes out the other end is going to be your database design. Now, again, looking at this dog license, those two approaches are very doable. The first approach, as I said, I would sit people in a room, the top-down approach, and I would say, what is the overall purpose of what we do business for? So we're looking at it from that business perspective. We track dogs. This is our animal control organization. Okay, and then we would work our way downward. I start talking about those entities, and we would start building a database from that, and then the software would be designed around that particular scenario. Okay, so that top-down approach, again, what questions would we ask? We would look at those entities. We would have that general purpose to license dogs. What attributes do those dogs have? We would say dogs have owners, dog have license numbers and expirations, dog have past licenses, dogs have impounds. And then we look down at the rest of those nouns. Licenses have fees. Owners have dogs. We try to retain those relationships in that top-down approach. And again, this is a very effective approach. You know, in some scenarios, one approach is good over the other. I found 6 of one, half dozen of the other. It just really depends a lot on the competency, and I don't mean that as far as intelligence, but the competency of the stakeholders. Are they technology competent? Have they done this before, or is this brand new to them? The bottom-up approach that we would use, here's some specific examples. If I get these people around the room, I would like to be able to return licensed dog to owners. I want to identify expired licenses. I want to send out renewal notices. I want to track impounds. This is that bottom-up approach. These are all the needs that each of my stakeholders want, and then it's my responsibility to take these needs and try to cohesively, again, put them into some kind of approach. So again, in that bottom-up approach, you would identify those entities. The entities would typically become tables, not always, but generally become tables. And then you identify the attributes. And again, you should understand, this is not a design class per se, but I want you to understand all those things that are involved. It's not as simple as simply sitting down and designing a simple table. There's a lot of thought process that goes in. Now, if you're simply going to track a coin collection, or you're simply going to track members in a club, it could be very simple. But if you're going to track dog licensing, as you can see here, it might be far more complex. So again, either the top-down or bottom-up approach, the database designer along with those soft developers are the ones that sit down and they physically design that scheme. You know, you can't, the database designer has a different perspective than the software developer does. So your design approach is going to be a head-to-head approach. You're going to work with both those entities together. And oftentimes you'll find out that the software developer may not know as much about database. So that's where you come in, folks. You are going to be that software developer that knows about database when you're sitting down talking to the database administrator or the database designer, or if you're that person, perhaps. So let's talk a little bit about the approaches of designing it. To design a database, and I'm going to give you two different approaches, folks, in here. First of all, my responsibility to you is to first show you how you do it by hand at the command line within that query window, if you will, because you're going to need to know how to do that later, and I'll give you examples of that. But at the same time, I'm going to show you how to use the designer. Because, look, the fact is if you're designing a database for the first time, or if I'm designing a database, and I've been in this since the 1970s, folks, if I'm designing a database for the first time, I'm certainly not going to sit down and use a command line to design my database structure. I'm going to use the tools that are at hand that are going to make it much quicker and more efficient. I'm less likely to make errors when I use a designer. And I should have access to everything in the designer that I get from the command line. But at the same time, what I'm going to find out though is there will be times with you as a designer, both as a software designer or as a database designer, where you're going to have to design scripts. And scripts are going to mean you're going to have a series of SQL statements to go together where you might be massaging data or moving data around or calculating data. And you might want to do that to a temporary table, or you might want to create a table in memory or create a table actually on your server. And for you to do that, you have to know how to do it by hand. So the fact is, again, as I mentioned, probably 95% of the time, if you're going to deal with a table, you're going to use a builder, and I'm going to show you how to do that. But that other 5% is what's going to make you very valuable to your employer, and we're going to go through that as well. So, assuming that you have the permissions, which you do not have on my SQL Server, to create a database, a default database, you would type in create database, and in this case, dog license. And what it would do is it would generate a database with default settings called dog license. The default settings depend upon how your SQL Server was originally set up, but the default settings, if you will, if you don't change them, would be that dog license database would be set up. Initially, it would be given, I believe, 2 megabytes of data, and then if you start getting close to that 2 megabytes of data, it will increase automatically by, I believe, 1 megabyte. And you can control this in a design, folks, but by default, it will auto size itself as it needs to. Now, that could be dangerous because you could easily fill up a server. Not as likely today as in the past. So, again, if you have the ability, the permissions, you can type in create space database and the name of the database that you want to create, and that statement alone would create the database. Now, designing the tables. When you design tables from entities and fields, you're going to do that. You're going to design those as attributes. In today's database management system packages and a DBMS package, let's talk real briefly about that. A lot of people, you'll ask, what database are you using? And they're going to say, I use Oracle, or I use SQL Server, or I use MySQL. That's not accurate. Your data is stored on SQL Server or Oracle or MySQL. The DBMS, the Database Management System software, is the software used to manage the data that you're saving. So the DBMS package would be SQL Server, or the DBMS package would be Oracle. So in today's DBMS packages, Oracle or SQL Server, fields can easily be added or changed. In the early days when I would design a database, or if I designed a table, and then later I decided that table structure needed to be changed, which is a very common thing today, folks, I would have to actually recreate that table with the new structure, with the added field into that, or if you will, the remove field, and then move my data from the old table into the new table. Nowadays, I don't have to do that. In fact, in the last 10 years, 15 years, I haven't had to do that. Now, if I simply go back in and add a field in my designer, it will automatically recreate that field. It will drop the old table, recreate it, and add it with the new table name as though it just recreated it exactly the way I wanted it. So once you've identified those attributes of the field, so again, this is talking about I've recognized now that I need to create a dog owner field, a dog owner table, if you will. Now I need to sit down and talk about the attributes or the fields that I need to add to that. And I need to decide when I add those fields, what kind of field is it? Is it going to be a numeric field? This is very much like when we do variables, when we're writing programs. You have to define the data type in most strongly typed languages. So if you're going to store a integer, you want to define a variable that's of integer data type. The same thing holds true when you design a table. You need to decide what kind of data am I going to store within this respective field. Is it going to be character? Is it going to be numeric? Is it a date field? Or is it perhaps a Boolean field, a true or false field? And at the same time, is it a required field? Is it a field that has to be filled in? Or is it a field that's an optional field? For example, if I'm asking for a student's information going to school, The first name and the last name pretty much are required. I'm going to require those fields. You don't have a choice. If you try to write a record and not store those, I want an error to be generated. So I might also want to go back in and put restraints or constraints, if you will, on my data. So a license number. I may know that my license numbers that I issue out for dogs always are going to fall within a range of 10,000 to 99,999, and if I ever try to put a number in lower than that or higher than that, I would know that it's an invalid number, and I would want the database to come back and generate an error for me. So those are the kind of things I need to think out. Not just the fields, but do I want to control what goes into those fields? Another example might be street direction. I know that if there's a street direction in my community, there may only be 5 possible entries: a north, a south, an east, a west, or maybe even a blank. So whereas in programming we have string or int type data, there unfortunately are different data types that we're going to find when we're dealing with a table. And what I've got on the screen here are the most common data types, and let's just briefly go through them. And of course, these are categories, so there's going to be different data types perhaps within each of these categories. So we have binary type database and character and date time. But within the binary database, we're going to find out that we have 2 different types of binary. Now, binary is going to be data that in this course we don't use, and I have not used it real commonly in my career. I've used it a couple of times. But what we can actually do within a table is we can store binary information. I can store a music file or a picture or an entire movie, if you will, or a spreadsheet or a Word document. I can store that into a given column, and for me to store that data, I would set it up as a binary data type. Not common. Well, it's becoming more common, I should say. Then the next type we have is character type data. Now, character type data we've talked a little bit about before. We have char data, we have varchar, we have nvarchar. Now the difference is char data is the oldest data type. Generally when I do this, I also have to specify the number of characters I want to store within this column. So I might do char 10. If I do char 10 and I store my name Tom in it, what it will do when I return that data is it will return back Tom with 7 spaces after it. So that's the old data type. Varchar is a variable character data type, and what it does is it's the same as char, but if I store Tom to it and I ask it to return back that particular column or field, it's going to return back just TOM, just Tom, not the trailing spaces at the end. So you're really not going to see char used very common today. We're going to use varchar. Now, varchar is based on the ASCII character set, which is the American National Standards. If you want to store international characters into your table, you're going to use the nvarchar data type. And the nvarchar data type basically comes back in, and it's a Unicode. It lets you come back in and select any Unicode type character that exists out there. The next data types that we have are date and time. And date and time are important because we could store a date and time as a character, but if we did that, we couldn't do mathematics on it. But by storing a date and time mathematically, we can add days, we can figure out the differences between 2 different dates, if you will. And we're going to find that there's some different types of data types that exist out there. This slide talks about just date time and small date time out there. But there's also another one out there that is just called date, and another one just called time that exists. And what are they for? Just that. Date time stores an exact date time stamp, if you will. You can store today's date and the exact time to it. And it goes down to the nanosecond. Small date time just goes down to the second. And then if you're dealing with date, it stores only a date, and time just stores only time down to the nanosecond. The next data types that we have are exact numeric. Exact numeric data types are just what they say. You will store exactly a specific data type. So one is decimal. In decimal, I can say I want to store a decimal number and I want to have exactly 2 decimal points. Or I want to store money and I want to have just exactly 2 decimal points. It's not going to go any more accurate past that point. So they're going to be pretty exact numeric types. In most cases, we're going to use what's called a floating point data type, though. And a floating point data type allows us to have as many decimal places as we want after that. And it's, again, a little bit more common to store numbers as a float or as a decimal type data out there. And again, accuracy is extreme. You're going to find out that we've talked about this before. I can go out to approximately, what I want to say, in a couple of hundred places past a decimal point if I was dealing with floating point. And then we have the next data type, which is bit. And there's only one type of bit, and bit is Boolean. Unfortunately, in programming, we call it a Boolean data type. In tables, we call it a bit. And in a bit data type, we store either a 1 or a 0, and it will be resolved oftentimes back as a true or a false for us, but we're going to treat 1 as true and 0 as false when it comes to bit. And then we have an integer data type, and an integer is a whole number without a decimal place. And we'll find out that we have, depending upon the data containers that we have int, small int, and tiny int. Most commonly, I'm going to use an int data type. And really what it decides is how big is the container. A tiny int, I believe, only stores up to approximately 256, whereas a small int, I believe, stores up into the 32,000 range. As far as plus or minus whole number, and then an integer will hold a very large integer type. And I believe there's also now a big int that we have. But from a business standpoint, most everything we want to do will be held with an integer data type. So, tables themselves. Tables can have names up to 128 characters in length. But typically your table name isn't going to have many more than maybe 20 characters. You want to make it descriptive. Something like you see on a slide here where you have a table of employees or orders or order items. You don't have to make it really, really large. And a table can have up to 1,024 fields or columns in it. Now, if you need to have more than 1,024 fields, you can do another table and do a one-to-one relationship. So you can actually, and you could do that as a view and have as many different columns as you want in it. But a table by itself can only have 1,024 columns. I have never created a table that was that large, nor would I ever want to. There's something probably wrong with a table that is that large. Column names must be unique in a table and suggested to be unique within a database. So what I would suggest is you don't create a field called an ID field and let that be your primary key or your entity field for all your tables. Now granted, I can have an employee.id or an orders.id, but it's much easier to look at your code and see that the employees table has an employee ID field in it rather than just an ID field. Again, you can get away with just calling it ID, but from a design standpoint, I would recommend that's not the best idea. Now, we've already talked about how to create tables once before. We know that we can create a table that is a spin-off table. Now, let's take a look at this guy right here because I'm going to have a cool trick to show you in just a second. So what this table does right now is it's going to create it's going to take all the fields that were in the players table and it's going to copy it into a brand new table called CA players, but it's only going to put those players in it that were born within the state of California. So this is a spin-off table. And when that spin-off table CA players is created, column for column, it will be a mirror image of players with a couple of small exceptions. And that is that any of the keys will not be copied across. The primary key will not be copied across, nor will the identity field be copied across. But all the data will be copied across along with the data types, as well as if it's character data, the length of the fields will match exactly. Let's take a look at this guy again in action. We've done this once before, but I want to show you one other trick as long as we're at this here. So let me come back over here. Let's go into baseball right now. Let's create a brand new query in here. And what I want to do now is I want to create a new table, a spinoff table, and I want to call that spinoff table just to show it. Let's go back and I'm going to grab my California data that I had before. Bear with me while I do that. I'm going to copy it off my slide, paste it in, and then correct my apostrophes because that's what PowerPoint does. Okay, and then I'm going to check my work, and I'm going to execute it. Okay, now it says there was 2,216 California records that were copied across. Let's just prove that's the case. Okay, so let's refresh our screen, and there's California players. If I look at the columns, I will see I have all the columns with the data types and the null settings that I had off the original players. Let's prove that, players table, except I don't have the key set. So notice again, all the data types matched, but the keys didn't match over here. So now to drop that table, let's get rid of that table that I just created. Okay, to do that, I would do drop table if I'm doing it the command line, and then the table name, CA players. Okay, now the other way to do that is I could also come back over here, do a right click, and come back and delete here. But if you're writing a script later and you're writing this in your program and you're passing it, you don't have access to do a right click. It has to be able to be done over here in the command window. So let's go ahead and do this right here. Let's drop it. Let's check, make sure the format's correct. Drop what the type is and the table name. I could do a drop view in the name of the view as well. And it's now gone. If I refresh over here, I'll see that it's gone. Now let me show you a real quick tip here. Sometimes you're going to need to go back in and create a table that you just want to play around with that has the exact same structure as the previous table. Let's say that I want to create a structure that has the exact structure of players in it, but I don't want to copy any data. I just simply want the structure, let's close this out here, of players, the exact structure copied, but I don't want any of the data to follow. Now, why would you want to do that? Well, again, occasionally I might want to manipulate data a little bit, maybe play around with data without jeopardizing my original data, or I may want to create a table where I'm copying data into it. Where I've used this before is in the past when if I had to create a structure and I want to modify the structure, I could spin a table off and make some subtle changes to that. Or maybe I just want to test my structure around a little bit. So in order to do that, to make a structure, and I'm just going to call this my players, we'll call it players work table. Okay. If I leave it like that, it's going to copy all the data in. But check this out. If I say where, and I just give it an impossible select statement, 1 equals 0. 1 can never equal 0, so I'm saying copy all the records where 1 is equal to 0. There are no records where 1 equals 0. Check this out. Okay, it says it's going to work. I execute it. It says it worked, but it copied 0 records. Uh-oh, let's go back and see what that meant. Let's do a refresh. And there's my player's work. If I look at it, there's my structure. But if I select the top 1,000 rows, there's nothing in it. So it's kind of a work table I could use to play around with. And then I'll use the other method for deleting this players out. Let's delete it. Now, I guarantee you that what I just showed you is going to be something that you're going to want to use later. Okay, let's drop that table. Let's jump back over to our slideshow. So, we don't use Management Studio in there. That should say Management Studio, not Query Analyzer. Let's take a look at how to build a table. And I'm going to spend some more time later coming back in this with you, but I'm going to show you the basics behind how to build a table in a designer, and then we're going to look at how to do it by hand. Okay? So, let's assume now inside baseball I'm going to create another table, and I want this table, I'm going to create it right now. I'm going to call it my membership table. Okay? To create a new table using a designer, I simply go to tables, and you folks aren't going to be able to do that within my baseball 2015 or within whatever baseball table I'm using right now. You will have to go back in and use your copy tables in order to do this. You can't create anything within my databases. You have only read privileges. So I'm going to do a new table, and then right off the bat, it's going to ask me what is my column information. So the very first thing I need to do is ask in my membership, what do I have that's uniquely going to identify one member from another? So I could go back in here and ask them for their driver's license number, but there's people that may not have driver's license numbers. I could ask them for Social Security numbers, but boy, that would put me at a risk for asking Social Security numbers, because then I would be responsible. So I don't want probably to have I'm just going to create my own primary key. But let's come back to that a little bit later on that. Let's right now not create a primary key. Let's talk about creating a primary key when I show you how to do that by hand so we can compare the two. For right now, let's assume that all I really want to do is track the person's first name. We're going to keep this simple. So first name, and I'm just going to go down a line first and create the columns, and then we'll go back and do the data types in a minute. Their last name, perhaps their address, city, state, and their zip. Perhaps I want to track, not the best example, but maybe I want to track their age. Well, let's do their birth date. Date of birth. Let's do date of birth. And let's see, I was trying to think of something I could do in here that might be numeric. Now, that's not a really best example because I can always calculate their age from the date of birth, but just for the heck of it, let's go ahead and put age in here. Okay, now let's go back in and add our data types. Okay, so first thing I'm going to do is create an nvarchar here. I'm going to use, or at least varchar. Okay, nvarchar if it's going to be international, varchar if it's just going to use American characters. So let's just fail safe it to nvarchar. Okay, nvarchar. So by default it gives me 50 characters. That's probably pretty safe for the first name. So I'm just going to head copy that. I can type the same thing in, but I'm just going to paste over the top of that one. Maybe the first name only takes 30 characters. Okay. And this is where the theory class comes in, is analyzing your data and trying to figure out how big to make it. Now later, if you find out that you need more characters for first name, you'll be able to go back in here and simply change that to a 40, and it will rewrite your database or your table for you and allow those additional spaces. So let's work down a line here. Address, let's allow 50 characters. City, let's allow 50 characters. State should only be 2 characters. Now, zip. Zip's an interesting one because although zip is numeric characters, it's non-numeric. What do I mean by non-numeric? Well, you don't have to add zips together. You don't average zips. You're going to find out that you cannot really put this in as a number. If I put it in as a number, even a fixed number, 5 characters, then I would have a problem with someplace like Massachusetts that has maybe a 00435 zip code, where it would throw those first 2 zeros out and make it 435. So I really want to have all 7, and I want to treat them as characters. So I'm going to have this guy become a varchar, either a 10, if I'm using a 10 digits, or more commonly 5. Date of birth. Now let's take a look at some of the dates I have. I've just got a standard date if I want to just track a date alone. Okay, I've got a date time, and a lot of developers will default to a date time, even though I may not know what the time the person was born at. You'll see there's some older legacy versions out here. There's going to be a small date time, and then there's a standard time, and it tells you how many characters it's setting aside for it. Let's just come back in here and set it up as a date initially. And then down here, we're going to use a integer for age. There should be no 1.5 years of age or whatever. Now, let's look over here on the right-hand side and decide what has to be filled in from our users. Maybe we require them to have to give us a first and a last name, but maybe within our membership, we don't require them to have an address, a city, or a state. Okay, now, maybe require a zip code, maybe not. We do want to have their birth, and maybe age is optional. So when we go back in and add a record, it's telling us that if we don't include a first name and a last name and a date of birth, our record will fail. It will not allow us to add it because we're telling it what has to be required here. Now, I'm going to go ahead and I'm going to save this. Now, as I showed you before, if I hit this button here, close, and for some reason I had an error in here, it would point the error out and throw me out and require me to come back in and rebuild again. But rather, if I come up here and I first hit save, it will ask me what my table name is going to be, and I'm going to call it members. Okay, and then I click OK. Now I can back out of it. Had I had a mistake there, it would have showed me the mistake and it allowed me to go back in and correct it. We're going to leave it at this right now in the builder. But notice what I've done so far. I've defined a column name, I told it what the data type was, and I told it whether it could allow a null or not allow a null over here. Okay, we're going to leave this as it is. Let's back out of here. Oh, and I do want to show one thing before I finish. Let's refresh the tables. There's my members, and if I open it up, there's the columns that I just created. Let's go back in and design it again. Because I realize now, and whether there was data in here or not, folks, it wouldn't make any difference. Okay, I need to add in here perhaps another field. In fact, let's decide that age is not required. I want to get rid of age and I want to add in another field. Okay, I can simply come back over here to age, delete that column out, and then come back up, and now I really want to do is I want to add in an email account. Okay, and over here, let's make it a varchar 50, and let's add in, make it 100 characters for large ones. And do we want to allow nulls? Now here's the catch, folks. If I already have data that exists in my table, then I can't change this because it will not know how, if I've got 50 names already out there and I tell it don't allow nulls, it's going to say, wait a minute, I'm sorry, I've already allowed nulls because I don't know what those other 50 names have for an email. So in this case, I don't have a choice. I have to tell it to allow nulls if data already exists. Right now, it will let me get away with it because I haven't added any records in yet. But had I had one record in here, it would not allow me to change this option right here. Okay, right here I'm telling it that it's not required. I do think that email should be required. Okay, since this is a computer program, we're probably doing this online. So now I'm going to save it. And notice the changes were made. Now before I go on, and I might have to dig for this a little bit. If you're running through this and you have an issue, by default, to protect the tables, Microsoft has turned off your ability to modify an existing table, to make changes to a table. So give me a moment here. If I go to Tools and down to Options, and I'm going to have to dig around here real quickly here where that is located at. Let me pause and I'll come right back when I find it. Okay, folks, I found it here. If you have a problem, again, as I just mentioned, and you're unable, you get an error when you try to save your changes, you'll need to come back into Options. Let me come back and show you again. Go to Tools, Options, and you only have to turn this on one time. Go down to Designers, And inside Designer, you'll see this feature right here. It says prevent saving changes that require table recreation. Okay, your check's probably turned on. If you had an error, you want to make sure that that check is turned off, and then it will let you continue. Okay, so I got that turned off. Let's finish this up and let's jump back to our PowerPoint slides. So let's go back and talk about how do we create a table by hand now. So we just looked at how it was done in the Designer. Let's come back in and talk a little bit about how we do it with a create table command within our query window or query designer. So you start off with the create table and the name of the table you want, and then all the definition of the columns will be within these set of parentheses right here. And this looks like gobbledygook, so let's take a look at an example of it, a little simpler one. So here's an example of creating a table called member. And in this example, I'm using an old legacy char data type, but look at what we've got here. We've got create table, the name of the table that we're creating, and then within the parentheses, we have the definition of that respective table. And then inside, we have different rows in here that are going to represent the columns that we're creating. So the first column is name. All we have to do is provide one space afterwards. Here there's been a couple of spaces. Name, a space, the data type that we're using. So I would suggest that rather than char, we would probably want to use varchar or nvarchar. And then notice over here that we have not null. So if it allows a null, we don't have to put a thing in here if nulls are allowed. But if we want to not allow a null, we have to put not null right after it. And that would then create a table that is called member. So hold on here. Let me come back over. I'm going to grab that same command and let's try it out. Give me just a quick second here. And I've got members over here created. Let me paste that code we just looked at in here. I've got the create table. So notice what we've got a little bit different here. I've got a full name. I'm just going to call it name, address, city, state, zip, donation. It's going to go to member, and let's not use member here. Let's put club member here because I've already got a members, and it should be club members. Club members tracks a record of member. And then let's check this out. Says it's good. Let's execute it. Says it worked. Let's come back over, refresh. And there's club members. And there's our columns inside. So pretty simple to create the basic table. Now before I continue on, folks, odds are this is the most that you're going to really need to do if you're writing a spin-off table. And I could actually create a temp table like this. The problem is when my script finishes running, my temp table is going to die. Let's see what happens here. Let's try this. I'm going to drop club members over here. Let's delete it. Click OK. And now let's see if it lets us create a club members table this way. It did. Now let's do a select star from club members. And IntelliSense knows it's a temporary table. And let's see what we come up with. So you see it's there for the session, so we could create a temporary table, and if I refresh over here now, I will not see club members because it's a temporary table. And actually, check this out. I can drop table club members. And now prove it's gone. Doesn't exist any longer. So let's continue on. Hopefully that was pretty basic. Again, this is probably as far as we would normally need to go with you as a developer to create a table that you might use to massage. But I'm going to go a little bit further and show you some more of the advanced features as long as I've got your attention. Okay, so it's always a good idea if you're going to modify a table structure, not so importantly if you're adding fields, but most definitely if you're going to drop or delete particular columns in a table, or you're going to modify the structure. You're going to reduce the size of a column down because you think you don't need as much space, or you're going to enlarge a column anytime, because remember, there's no undoing this. So anytime there's changes made, I suggest that you do what's on this screen here, and you do a select star into and make a backup table from your data, so that if any problems occur, you've always got that data that is backed up. Now, there is an alter table command that exists. An alter table command allows you to go back in there and add in a column or modify perhaps some of the constraints of a column, if you will, after the table is created. Now, before I go on, the fact is we as developers are never going to do this. First of all, why would you want to alter a table most likely that you just created in a create table command? You're going to put that in the original create table command. If you need to alter the structure of an existing table, you're going to do what I showed you a moment ago in the Management Studio. And in the Management Studio, you're simply going to go back in and you're going to adjust the column information after you make a backup, of course. But nonetheless, there is a way that you can alter a table, and I'm going to show it to you in a slide. I'm not going to spend time going back in and showing it to you in a demo because, again, I don't think you're going to be likely to use it. So this first example is alter table, whatever the name of the table is, and you're going to add a column name, and you simply got to give it a data type. Okay. You can also drop an existing column if you want to. Okay. Or you can alter a column's existing data type if you want to. Okay, so I'm not going to cover that with you. Really what I want to do is spend more time on the commands that you're more likely going to use, like a drop table command. So a drop table, you saw me use it just a moment ago on a temporary table, or maybe a table that you're generating in a script. And remember, a script is a series. We'll talk about this and give examples later. A script is a series of select statements that run one by one. We've done that already before. We put two selects on the screen and we run when we get two outputs at the bottom. That would technically be a script. But there's a lot we can do with scripts later. So I can drop a table. We saw that done just a moment ago by doing drop table and the table name that I've got. Now also, I could drop a view, as I mentioned before. I can drop a temporary table doing the same command if I want to. Or I can go back over into my Management Studio, do a right click on the table name, and tell it that I want to delete the table name, which would then effectively drop it for me. Primary keys. Now this is where we're going to get into some areas that are not as likely that you're going to use. If I want to create a primary key, there's two different ways at the designer level that I can create a primary key. The first way is that I can go back in and right in that same column that I'm creating, I can then give the name primary key, and at that point it would then, and that's the bottom example here, it would create the primary key. Or at the very end of my design, at the very bottom of my design, I can just put a line at the bottom of my create table line just before the empty parenthesis and say primary key, and in parentheses give the field name that I want to call the primary key. Now, odds are the best method is probably going to be the second method. The second method you're going to put right down here, right after the column you want to be the primary key. In this case, I want counter to be the primary key. The moment the counter becomes a primary key, by the way, it becomes a unique column, which means there cannot be duplicates anymore. The definition of a primary key says it's unique, so it's going to automatically establish that rule for me. Now, where this will come in more handy is if I have more than one column I want to be my primary key. You'll recall that when we dealt with our weather table before, I had two different columns. I had month and day, two columns to be my primary key. I cannot use this bottom method for that, so here I would have my primary key be my counter. I would have my primary key be my month, comma, day, and that then would serve. So there is a separate use for this first example, if you will. So Again, the primary key constraint is required in tables. The one we did a minute ago, we did not have a primary key. You cannot allow nulls in a primary key by definition, because the moment you had two nulls, you would violate that primary key constraint that says no duplicates. And a primary key can be 1 to 16 columns in length, but it's rare for us to use more than one. You saw us use more than one. We had that weather database that we've been using. So here's an example of adding a primary key to a particular column. What I did in here is I created a table called sale, and sale has two different columns. It has a sale ID column and it has a name column in here. The sale ID column, we're going to talk about this in just a moment, let's ignore this for right now, is an integer data type, and it's going to be the primary key right here. Now, what I could have done is right here at the bottom, I could have gone down below and said primary key, and in parentheses put sale ID down here. But this would be the more appropriate way when you're having a single column done. Now let's go back to our example we had a moment ago. Oops, pardon me. And right here. Okay, let me get this pulled out. If I wanted to create a primary key in here, and let's put, we'll recreate club members again here. And what I'm doing now is I'm going to go ahead and add in a, let's call this a club ID. Okay. For right now, I want it to be an integer, and I want it to be my primary key. Just like that. Let's check it. Everything looks okay. Let's execute it. Says it worked. Let's refresh our tables. And here's our club members. And let's open our columns. And voila, there's our primary key. Now, the challenge with this design, which we're going to address in a minute, is that I have to fill in this primary key number every single time I add a record, and I better remember what numbers I've used, because if I try to reuse a number again, I'm going to have an error. Really, what I'd like to have happen here, as we're going to talk about in a minute, is I want the computer to generate that number for me. We did it before. Let's take a look at how that's done again. So, the identity columns. You can have one identity column per table. And the identity column, if you're used to dealing with access, would be called a counter field. This is what I was just referring to a moment ago, and that is a field. An identity field is a field that SQL Server will manage for us, and as we add a record, it will automatically increment that field for us, and it will never allow an identity number to be reused. For example, if I went in and I've added 1,000 records in, and it's now numbered 1 to 1,000, and I delete record number 5 out, when I add the next record in, it's going to be 1001. It will not be 5. And if I try to add a record 5 in, I will get an error. It will not let me reuse that again. And that's important, because you don't want a customer ID to be reused, even if that customer is no longer your customer anymore, because you have records that you might want to retain, child records that you don't want pointing to somebody else at a later date. So, the column must be of an integer type, big int, small int, or a tiny int type data type. You cannot allow nulls, obviously, in that field, because a null is non-numeric, it has no value. And the column cannot be updated. It's managed by SQL Server. You cannot go back in there and add in a value on your own. You have to let SQL do that for you. So in order to do that, it's a simple statement here. Okay, and the easiest way to do that is, as we saw in that previous example, is to simply go back in there. Oops. Let me jump back here again, I'm sorry. And add in the keyword on the column that you want, identity. You then tell it what the starting number is and the increment, and it will assign it automatically. So using this example right here, it would automatically assign the first number as 100, and then as I increment through it, it's going to increment 100 by 1, 101, 102, 103, and I will not be able to come back in and monitor, or modify this counter field right here. Let's go back in and add that in to our table. So what I'm going to do is I'm going to drop this table again. Let's delete it. I could do an alter if I wanted to, and add this column in with an alter, but I don't want to, because it's not likely I'm ever going to do that. I'm going to do it the more likely way you will. Right there. Okay, now I'm going to add in an identity field, and I could put this, by the way, these constraints can be in any order except for the integer has to follow. So the data type has to follow. So I'm going to do a identity, and then after identity, I'm going to tell it I want to start it at 1 and I want to increment it by 1. I could start at 100 and increment by 10s if I wanted to. Okay, let's check it. Uh-oh. And let me see what I made my mistake on here. Hold tight. Let me just pause for a moment. And of course, it's a common mistake here. I spelled identity wrong. Identity instead of identity. There we go. Let's check it. There we go. Let's execute it. Now let's go ahead and open up that table and just take a look at it and make sure it works. Whoops. Refresh. Club members. Let's open it up. Design. Tells me it's a primary key. Let's go down below here, and identity, yes, and 1 by 1. There we go. So it's all set up. Let's close that out, and I'm going to drop that table again. So back over. Let's talk a little bit about data integrity. The data integrity talks about making sure that your data stays accurate. There are 3 different categories of data integrity that we can take a look at. The first one is what's referred to as entity integrity. And entity integrity says is that one row is differentiated from another row. A primary key, or what we'll talk about in a minute, unique type keys, provide that. A primary key says is that one row has to always be somewhat different than another row. So one entity has to be differentiated from another entity. That's the primary key. You can also do that with a unique key, but the primary key is guaranteed to do that. There's another one called domain integrity, and domain integrity is concerned with the integrity of the data that we put into that column itself. So something like street direction could only be in a north, south, east, or west, or maybe a space. Allowing a Q in that would violate that domain integrity. Domain integrity also comes back in, and it's covered by the data type. It has to be of type number, or it has to be of type character, which is of char, or it has to be a true-false type data. Those are the types of things we talk about as domain integrity. Then we have referential integrity. And referential integrity says is that when I relate a parent to a child, I expect a proper relationship. If I'm doing baseball relationships to batting, for example, I'm doing player to batting, I want to make sure that when I pull up Babe Ruth's player record, that I can always know and expect that I'm going to get Babe Ruth's child batting record, or his salary record, or his pitching record, knowing I'm not going to get somebody else's. And that's the referential integrity that we talk about. So these constraints that I want to look at next, and constraints are any of those rules that we put on our data to make sure our data is accurate. And going back before, we're going to take a look right now at the domain integrity. We've been playing around with domain integrity when we take a look at the data types that we have out there. The fact that it's not a null field. Those are also constraints on the data, the rules that we put on the data. There's 3 different types of constraints when we're looking at those types that we deal with. Procedural are those that we rely on that are going to come out of the database themselves, procedural. So those are things like when I create a view, or we'll talk about triggers or store procedures later, but when I create a view, I can set rules on those views by showing particular columns or hiding particular columns. or changing data, if you will, to constrain that data back to the user, to make that data look to the user the way I want it to. Declarative integrity are the constraints that are placed on the tables, the specific ones that we place on those tables. That's the ones we've just been doing. Those are the ones where we set the rules when we design that database. And then we have the programmatic rules. And the programmatic rules are the rules that we as programmers place on the data that are outside the database. For example, I know I don't want the database to tell me that if it's asking for a north, south, east, or west, or a blank, that when I put a Q in there, that it's going to come back and generate an error and I have to deal with that error. As a programmer, I'm going to make sure that when the user selects the street direction, that they can only pick among those 5 different users. So it's between these 3 groups of constraints that we set those rules up. We either set it up in how we let the user see the data, we set it up on how we design the database, so we set it up as programmers on how we write data to that database originally. And there's obviously all 3 of these overlap one another, and we want to make sure that those rules are as concise and are complementary as possible. I mean, I might at the same time want to make sure that my program only allows numeric data to be written to a numeric field, but at the same time that field in my database is only going to allow numbers. So, declarative constraints. We can put declarative constraints both at the create table when we do it in the designer, which we will take a look at in a moment, we've been looking at as well, but we can also put it in our create table or our alter table commands, and we're really going to focus on the create table side of it. And these are constraints that we're going to add in within the column definition themselves. Let's take a look at that. So there's one called a check constraint. And a check constraint is done at the column level. And all I have to do is when I define that particular column, and of course this is just a subset of what probably would be a bigger table, but I'm just showing you one column in here, the salary. So salary is of type money. It has to be filled in. That's what that not null says. It can't be null. And salary cannot be less than 100,000. If I try to put a value in that column, this check constraint is going to make sure that it falls within that range. So if this was a street direction, for example, I could say the street direction has to either be north, has to be south, east, west, or blank. And I could even use an in statement as we've used in the past. So the check statement is very, very, very powerful. And within my design, for example, over here, I might want to, within my club members for donations, say, and I'm not sure why I might want to do this, but I might want to say that let's make sure that the check that the donation, and by the way, I can use more than one column to validate this. I can say donation times some other column that might exist in here. So that check can be pretty strong as well, but I want to make sure that the donation amount is greater than 0. I don't want somebody donating a negative amount, which probably is ridiculous to put in here, but nonetheless, this is an example of one that I might choose to use here. Let's continue on here. Default data. So what I might want to do is say if a user doesn't put a value in, then I might want them to default that data to a particular value. So what would I do over here on my design on this side? I might want to come back in here and say, you know what, if my user doesn't put city, state, or zip in, I want to default it to Spokane, Washington 99207. Again, I'm not sure why I might want to do that, but what happens is if I leave this value as a null when I'm creating that record, this is the value right here that's going to be put in. So this could never allow nulls. The moment it tries to see a null, that's the default value that will be put into that column. And take a look here. Here's an example where I'm combining the two together, and I'm saying the check, the that check to make sure salary is less, in this case, than 100,000. But if they don't put a value into it, I want it to default to 30,000. Now you better make sure, of course, that this default falls within the same range as your check here, which it does. So notice again, same thing. This not null right here, it says not null necessary. Obviously, I could pull this not null out. It will never be null, so I could get rid of this because it's guaranteeing me that if it does try to be null, it's going to put a default 30,000 in. But whatever value I put in here has to fall within this range. And by the way, I probably would want to put these same rules on my program side on the other end. So here's another example of using a between statement. In this case, I want the employee ID to fall between 1 and 1,000. So you can see there's some pretty powerful rules that we can build in to these checks. But before I go on, I can do the same thing in a designer. So even though we can do it here, the designer will allow me to do virtually the same thing. Unique constraints. Now, I talked to you before about a primary key, and I told you that a primary key could be unique, but there may be other fields that I put in to my table that I want to enforce uniqueness. Say, for example, that I'm tracking a person's student ID, and I decide that's going to be my primary key, but I'm also tracking a student's social security number, a driver's license number. Well, in that case, I would make my student ID my primary key, and I'd want to make sure that there were never any duplicates to make sure my data is accurate in social security number or driver's license. So I would make sure that both the social security number and my driver's license number are going to be unique. It guarantees, again, no duplicates. If there's ever a duplicate, then an error would be generated. So whereas I can only have one primary key per table, I can have as many unique constraints as I want. And I could also say that a unique constraint is a primary key candidate, which means if I went back to this original design here and I had these fields and I'm looking at these fields, any one of these fields in essence could be my primary key, would uniquely identify a user, and I have to pick from these which one I want to be my primary key, and then I would make the rest of them a unique key. So in order to add a unique key, all I have to do is put that keyword unique right after it, and that then would make a unique field. Again, it's pretty simple to do. I'll show you how to use that in the builder in just a moment. I'm not going to go through a demo on all of these. When I do demo it, it will be in the builder. And then the last thing is the temporary storage files, and I mentioned that earlier in this demonstration, and that is that a lot of this stuff we can create as temporary files. If I put a single £sign before the table name, I'm creating what's referred to as a session, a temporary session table. If I do 2 £signs, I'm creating a server table. The session table basically is removed when you log out or when your session expires. If I put it into a store procedure or into a script, when the script stops running, the temporary table is removed. If I have 2 £signs, that is then a server table, and that is not removed, and these are dangerous tables, by the way. These are tables that are not removed until I reset my entire server, and some servers aren't reset. You know, I know some developers that will brag and say they haven't had to reset their server for a year. That would mean that these temporary server session tables stay for a year, and they don't stay within your tables list. You don't know that they exist out there unless you call on them. So again, to create that temporary table, you would simply put a sign in front of that table when you create it. And let's take a look now and close this lecture out by going back in and looking at the builder and what we can do within that builder. We've seen most of these before, but let's just go back in and review them. So I'm going to go back in. I'm going to go back to my SQL Server here. Okay, I'm going to open up this table right here in the designer. Okay, so I've already got it. Have I created it yet? Let me just see. Let's run it. It created it. Now let's refresh it. And let's open up the designer. So in the designer, you'll see that I've got this club ID here, and let's look at what we've got over here in a couple of different areas. So down below I've got column properties, and over here I have some additional properties as well. So as I highlight the column, the club ID, and I look down below here, you're going to see that right here is where I can enter my default data if I want to. So I could put in here if I wanted my data to default, and let's see what I got down here. Notice that when I click on city state zip, it's telling me my default data is Spokane, Washington 99207. Okay. And also notice that it has my column length in here as well, down below it. So there's my default data. If I look down below here, this is where, and we've done this before, I can set my identity field right here. So this field right up here is in fact an identity field, yes, and it is also my primary key. I can see the key on it telling me that it's my primary key. And if I look over on the right hand side, then you'll see some more information over here. It also tells me that it is an identity field as far as club ID. If I right click on any one of these fields in here, now I have access to two different areas. The first one I have access to is my check constraint. So with this column selected, let's say my check constraint donation here, and let's go down to my check constraint in here, and I can see that I've already got a check constraint created with donation greater than 0, because that's the one I created by hand. And if I want to modify it, it actually builds it with a name over here. I can check constraint name, and if I want, I can edit it right here, and it shows me that constraint. So I selected the column. Let's go back and review that again. Selected the column, did a right click on it, went down to my constraint, okay, and then I can add a new constraint in if I want to. Here's the existing constraint that I had. I see it over here, and the expression lets me key in that constraint, and I close it out right here. Let's see what else. Oh, last one here. If I right click on it, I will also see a thing called indexes and keys. When we're dealing with a unique field, that's really a key, an index, so, because it has to know and look at, and track all those previous keys. So if I do a right click on here, I'll see now that I already have a unique key set up. I added a key in here on the field that I selected, and over here it wants to know what's the type. And let's go back and create a brand new one. This is already done for me, and it's set as a unique one. Let me add a field in here, and I'm just going to call it an int. And let's not even call it an int. Let's call it type. Oops. Let's try that again. Type is going to be a varchar. Again, pardon me. It's going to be of type 10. And I'm not sure why I'm going to do this. I'll call this type here. And now let's create this guy, and we're going to come down here, create an index or a key. Okay, I want to add a new one in here, and it wants to know, based on what I'm creating, what is the type. And right here I can tell it it's a unique key. And that will then make sure that type can never be duplicated, meaning that I can type in type 1, type 2, but if I type a type 1 in again, I'm going to get an error or whatever, any kind of duplicate. So we've reviewed, again, setting up primary keys in the builder. We've reviewed the default data down below in the column. We've reviewed the identity columns as well. So at this point, you should understand the basics about creating tables, and I suggest that you just play around a little bit